All right, now the most yawn session, if you ask me, even though significant figures is kind of a yawn session, if you ask me, is conversions. Now, you should have a paper that's passed out to you with all these conversions on it. Really small writing is a reference for you. Do we do many conversions, though, during class? No. Even on tests, you got to be careful. You need to make sure they're right. But, like, I don't, like, try to trip students up on conversions. I mean, when it comes down to it, am I more concerned with converting or am I more concerned with how to do a problem? And I got to tell you, I'm more concerned with how to do the problem. But so be it. We're going to do a little bit of conversions. And I don't do, in physics, it's funny, in FSI I do the fence post, how other teachers would do it. And in physics I don't. I do, it's the same thing, like a factor labeling method with parentheses. Okay, it is exactly the same thing, but let's just write down a couple conversions that we know. 1 meter, 100 centimeters. 1 kilometer, it's not how I normally write them out, no, I'm doing it now this way. 1,000 meters. 1 meter, 1,000 millimeters. 1 mile, 5,280 feet. Stupid. It's kind of dumb, right? Like, how do you come up with this stuff? All right. And then 1 foot, 12 inches, and 1 yard, 3 feet, and so on and so on and so on. And ounces and cups and sticks, rods, whatever we use, okay? So be it. Seconds. I'm not writing down seconds. That's ridiculous. We should know that. So let's just make something up. Let's say we're going 5.0 meters, and we're going to go to kilometers. No, we'll go to yeah, we'll go to kilometers. Okay? So we know our conversion factor, 1,000 meters in 1 kilometer. So I start out by writing this first number over 1. I then have a conversion factor, which in this case is right here. We got to make sure that the meters cancel out and that we're left with kilometers. So our meters cancels out and we're left with kilometers. So 5 divided by 1,000, we move the decimal place 3 places to the left. 1, 2, 3. There we go. And that would be, what is that? 5 thousandths? Man, my brain's kind of weird right now. It's not school yet. 5 thousandths of a kilometer. Yeah, it makes sense. So that's it. Okay? Make sure the units cancel out, multiply straight across, then divide. You've done it before. Probably done it a couple years at least. So you should know how to do this. The one thing I want to say is, whenever we look at significant figures, okay, we always go with what's in the original. So this has 2, this has 2. Why is that? Why don't we look at the conversion factor? Reason is, it's an exact number. Okay? When you have exact numbers, okay, that have no measurement really to them, you do not count them in your significant figures. If I'm going to take a number and I'm going to multiply it by 2 to double it, you don't take 2 into account when you're doing the significant figures. It doesn't make sense. Okay? It's an exact number. Exact numbers have an infinite amount of significant figures. We do not take those into account. So let's do a little bit of a different one. With like a numerator and a denominator. So let's do, let's stick with this one. 500 kilometers per hour. 50 kilometers per hour. Okay. And we're going to go to meters per second. All right. So if you're ever in your car, you'll know here in the United States that we have a miles per hour, but you probably also see kilometers per hour on there too. I don't think I ever pay attention to it. So be it. So how do we write this? This means right here that you're going 50 kilometers in every 1 hour. The best way to get this correct is by writing it like that. So we have to get the kilometers correct and the hours. I'm going to first do kilometers. So I'm going to go over to my conversion factors again. 1 kilometer equals 1,000 meters. Okay? That way kilometers will cancel out and I have meters like I want. Okay? Now you'll notice up here, kilometer was on top, now it's on the bottom. Some students always put the 1 on top. They think, oh, that's just the way to do it. You always have 1 and then a number. No. Okay? Make sure you keep your numbers with the correct unit. And also we need to set it up so that if this is on top, the other one's on the bottom, they cancel out and they leave us with the unit that we need. All right? So that's correct now with the meters. And now we need to get hours. Well, there's 60 minutes in an hour and there are 60 seconds in a minute, so 60 times 60 is 3,600. 1 hour is 3,600 seconds. Okay? And we're good. So my hour will cancel out. I'm left with seconds, and so I have meters over seconds. That's what we need, right? So then I'm going to multiply straight across. 50, I can't believe I'm going to multiply. 50 times 1,000 is 50,000. That's about right. So, and that would be 50,000 on top, 1 times 3,600 on the bottom. So 50,000 divided by 3,600 is 13.9. And you'll notice, I like to box my final answers. Okay? I don't like them circled, and there's a reason for that, and we could talk about that later. But I like them boxed. It means it's the final answer. So, yeah. A lot of times I'll see students mess this up. They kind of write the 50 kilometers per hour like this, then they don't put the units top and bottom in the correct location, so they can't cancel them out. And that's that. Truth is, if we have iPads and we have computers, all you gotta do is go conversion calculator. But if the homework assignment, which you'll have, is on conversions, you have to show this work or it's not complete. If you just show an answer, then it doesn't mean anything to me. I want to see it worked out. Okay? And this is called the factor labeling method. It's the same thing as fence posts. If you like that, you do the fence post thing. That's perfectly fine. Right? Now, it was funny because in high school, to me, it's funny now thinking about it. I just did it. And then one time somebody asked, well, what is this? 1 kilometer divided by 1,000 meters. Like, what is that? Well, it's a conversion factor. What do you mean? And they said, it's 1. I said, it's 1. And I was like, oh yeah, I guess it is, right? So like if you take liquid in a certain shaped container and you pour it into another container, it looks different, but it's still the same amount. Pour it into another container, same idea. So really all we're doing throughout this whole time is we're multiplying by 1. This times 1 times 1 gives us a different number, but it's still the same amount, right? The car is still moving the same speed. But I don't know why, I just never thought about multiplying by 1 the whole time. I don't even know if that's a big deal to think about, but there it is. All right, so that's the end of conversions, and you'll have some work to do with that.